examples on Wednesday, and I'll give you some time for them. So we're looking at solving trigonometric equations part 2, where we have a b value that is not 1. So I'm going to ask for the last 10 minutes if everybody could be just listening, copying down if you desperately have to, but just listening would be great. What I've done on the side here, which looks really intense, but it's not that bad, is I've copy-pasted my 4-point plan for solving normal trig equations from earlier in the OneNote, and I've pasted it here. I've inserted a step 2 and a step 6, and this will be your 6-step plan, if you need a plan, for solving trig equations where you have a b value that's not 1. So these are slightly different, and they involve basically one extra key step at point 2, and some things that you do at point 3 and 4 that are important. So I'm going to show you this first example and explain what I mean as I go. Okay? The textbook, I think, and some places you'll see, will do a substitution here at the 2 sine 3x minus 1, because the key here is that 3x, the b value that's not 1, has to remain with the x until right at the end. Otherwise you'll muck up your work on the unit circle. Because you know how earlier we were adding 2 pi and subtracting 2 pi? We were doing that because 2 pi is the period. So you add a period on, you get to the next cycle. In this case, b is not 1, so the period is not 2 pi anymore. The period is now 2 pi on 3. Now, you can either work out the period and add periods on instead. That works. But I think the way I'm going to show you now is an easier way, which is to continue using the 2 pi and only divide the 3 out right at the end. And so I'll show you what I mean. So to solve this equation, step 1, you might recall, is to rearrange it to get sine x by itself. But in this case, that's getting sine 3x by itself. So I get 2 sine 3x is equal to 1. I've added 1 to both sides. And then I get sine 3x equals 1/2. And I've divided through by 2. So that's step 1. Step 2, which is a new step, is to reformat your domain. And at this point, you might do a substitution if you want to. So I'm going to do this over here. I'm going to line it up with my step 2, but I'm going to do it over the side. You might just do it over to the side. 0 is less than or equal to x is less than or equal to 2 pi is where I want my answers to come from. That means that for 3x, I want my answers to come from 0 is less than or equal to 3x is less than or equal to 6 pi. I've just multiplied everything by 3, so I know what values I want for 3x rather than x. Because I'm actually going to solve for 3x, and then I'm going to turn that into solutions in terms of x. So I've rearranged my domain now. I know where I want my solutions to be. 2 pi is my normal period, so I'm expecting to get 6 solutions because there are 3 periods, 3 full cycles in this domain. So I'm expecting 6 solutions. That's step 2. Step 3 is to use a calculator to find the reference angle. So I get 3x is equal to sine inverse of 1/2. And hopefully you are getting used to your exact values. There's a whole exercise practicing them. And sine inverse of 1/2 is pi on 6. That's your reference angle. The domain tells me to work in radians, so I'm going to work in radians. Okay, early on though in the game, if you really hate radians, and I'm sure that most of you do some questions where you convert to degrees, solve in degrees, and convert back to radians. That's not a big problem, but you want to be heading towards being able to use radians fluently. That's the plan. It is a little bit like learning a new language sometimes though. So that shouldn't be x, that should be 3x. 3x equals pi on 6. Now this is the key point, and I'm saying this really loudly on the video. Do not, under any circumstances, now divide by 3. It seems like you want to, but you need to solve the whole thing for 3x, and the last thing we do is divide all of our solutions by 3, even though it seems like that's anti what you would be thinking. So I'm going to do step 4 now of the normal process, and that is to find my second solution. So I draw a little unit circle over here. My first solution is pi on 6. I've got my cast diagram, and this is a sine question. So I'm looking for where sine is positive and positive, because it was positive 1/2. So sine is positive in the first and second quadrant, so my second solution is in the second quadrant. That's pi on 6 there. This is pi. And the second solution, which is here, is pi minus pi on 6, which is equal to 5 pi on 6. Now, I'm pretty good at pi fractions, and you will be pretty good at it too the more you practice it. It's good to get used to that. But you know what? In tech active exams, you'll have a calculator, but you've got to get used to how to do that calculation with a tech free exam as well. Pi can be written as 6 pi on 6 is the way that I do it in my head. So there's my two solutions. My two solutions are 3x is equal to pi on 6, or 3x is equal to 5 pi on 6. Now I get my additional solutions by adding, and I'll do it on my unit circle, by adding 2 pi to my first solution to get my next solution. So that's a period on, and so I add 2 pi, and then I add 2 pi again to get my next solution. So pi on 6 plus 2 pi. 2 pi is 12 pi on 6. So this next solution is 13 pi on 6. My next solution is 13 pi on 6 plus 2 pi, which is 12 pi on 6, gives me 25. And I've not written 25, sorry. 25 pi on 6. My next solution would be 37 pi on 6, which is more than 6 pi, so it's outside of my domain. So I could find additional solutions that are outside of my domain. And I'm going to do the same thing down here, adding 2 pi each time, and adding 2 pi. This is step 5, by the way, that I'm doing at the moment. Step 4 was that. And so we're pretty close to the end. Adding 2 pi, which is 12 pi on 6 to 5 pi on 6, gives me 17 pi on 6. And adding 12 pi on 6 to 17 pi on 6 gives me 29 pi on 6. And that gives me my 6 solutions. Another 12 pi on 6 to 29 pi on 6 gives me 41 pi on 6, which is beyond the 6 pi again. So I've now got my 6 solutions for 3x. To get my 6 solutions for x, I just divide everything by 3. Because I had 3x, I divide everything by 3. This is the last step though. I only do this right at the end, step 6. And so pi on 6 divided by 3 gives me pi on 18. And hopefully you'll see that every time I divide by 3, I just get, instead of 6, I get 18 as my denominator. 13 pi on 18, 25 pi on 18. And my other set of solutions are 5 pi on 18, 17 pi on 18, 29 pi on 18, and they're my solutions. To match that up with my list of rules again, rearrange to get sin x by itself, or cos x or tan x. Determine my new domain by multiplying through by my b value. Solve for the first solution for bx, for in this case 3x, not for x. Do not divide by b yet. Find the second solution using the unit circle for 3x or bx or whatever it is. Find subsequent solutions by adding or subtracting 2 pi or 360 degrees. And then divide through by b. If you divide through by b early, you will not be able to add 2 pi or 360. You'll have to add or subtract your new period, which is a method you can use. You're welcome to use that, but I do think it's a bit harder and tends to bring about more mistakes. So using my method is, I think, tends to be easier, more procedural, and less likely to cause you errors. But I'll leave you with that. We're about to finish. That's one example. I'll record this bit as well. My suggestion would be that you go home, you keep on working on these b equals 1 questions in exercise 15H. There is about 6 or 7 questions that has b not equal to 1. Read through my example again this weekend. Try and do one of those. Next week on Wednesday, I'm going to do example 5 and 6. No, I'm going to do example 6 and 7. And they are those questions again. And I will show you, run through that process all over again, exactly from start to finish. But if you come in on Wednesday and you've not done any more trig equation solving, you're basically back to the start. Okay, thank you.